We've looked at optimizing images using the WebP format, but what if we could also optimize our images for the particular device we're displaying it on based on image width, making those files even smaller? Let's mash on that.
Hi everybody, and welcome to another episode of the Asp.Net Monsters. In today's episode, we're going to continue our adventures in image optimization by looking at how we can trade off a bunch of disk space by keeping 300 copies of an image for bandwidth utilization. So what do you got for us?
Well, so just a quick recap. We looked last time at converting what we had as a really big JPEG image to a much smaller WebP image. And that got us from, when we ran Lighthouse, from a score of, what was it, like, we were at 80-something to 97. So, like, pretty good, but I'd really like to see that even higher because, you know, the main thing that I'm seeing now as a possibility is proper image sizes. So even though it shows it as passed, I'm a little curious as to why it's showing this as a rule that passed, because it's telling me that there's still a pretty substantial savings here of maybe, well, I guess it's not as big as it was previously, but we could save even more kilobytes here by resizing this image to something that makes more sense for what we're displaying. So I was going to take a look at that, and we can do that using that same picture element that we specified before. But first we need to figure out like what sizes do we actually want to display these images. So let's make
every size
changes.
Probably
every possible size.
Yeah, I think so. Like it's 3,000 pixels wide, so if we just start at 0 and go to 3,000 copies.
So I'm going to start with, we'll call it 4 different sizes, and then we'll just let the browser pick.
All right.
We'll let the browser figure out, depending on how it's going to render that image, which one it thinks is best. So I had my little image resizer thing here. I'm going to leave that original size in there, but I'm also going to provide one at 2560, another one at 1920, and another one at 768. And
those seem like familiar sizes.
They do. They're screen sizes that we might be familiar with, right? But we'll start with that, and we'll just kind of see what that does. So let's run my image minimizer again, and then we can take a look at the results there. How much smaller are those images? So now I have a bunch of these images in here. And you can see that they're quite a bit smaller. So the one that's 2560 width is down to 643K. So an even bigger savings again than Lighthouse was estimating, again, just because of the quality setting that I'm using. And then 1920 gets us down to 432K and 768 down to 109K. So the idea here is that, like, if we were displaying this on a mobile device, we probably don't need to download an image that's 3,998 pixels wide. We can probably get away with the one that's only 768 pixels wide, which would mean that we would be saving 1.2 megabytes. And on a mobile device where maybe we're on maybe not like the best cell connection, or we don't have a great internet connection at the time, that's a huge difference in how long it's going to take that page to load. So the way we incorporate that now that we actually have the assets, is we just come into here, and this source set, we can actually tell it, we can just list out all of these images that we have. And if we give the browser a hint here as to how wide each of those images in the source set happen to be, then the browser can use some heuristics to decide, based on how big that image element will be when it gets rendered, which asset is the one that makes the most sense to download. So I can come down in here now, and I can just specify, I list them all out, comma separated. So I'm going to do my 2560 wide, 560, and then I'm just going to copy these other two in here because it's kind of boring to watch me type that in.
Oh, I was hoping you were going to use multiple cursors, and then at least it would be exciting.
So there's 2 hints we have to give the browser here. There's this one that tells the browser how wide each of those assets happens to be. And then the other one is telling it how wide the image itself is going to be when it's rendered. So in this case, it's 100% of the view width, because that's what we have specified here, is that it's just width 100. Mm-hmm. We're going to look at tweaking that and showing how we could have it displayed differently depending on different breakpoints in our CSS. But just as an initial pass, let's take a look at this and see what it does. Actually, you know what? Before I do that, I'm going to revert that change because I wanted to run Lighthouse in mobile just to show the difference. Because it's going to be even more substantial there. We did have that 97 that was passing in desktop, but if we go look at the mobile version of that, so you can run Lighthouse for desktop or for mobile, and for mobile it simulates like a smaller device, but also a worse connection, like it simulates a 3G connection. So it takes longer to download those bytes. So here you can see that it's taken quite a long time. My performance score is a lot worse than it was. So instead of a 97, I'm at a 66.
Even with WebP.
Yeah, even with WebP. And here we're really getting penalized now for the proper image sizes because it's recognizing that instead of a 1.3 megabyte image, we could have just 100 meg K, or like a slightly over 100K image that would be sufficient to display. So that's before the change. Let's go back and make our change again. I just have it in the clipboard. There we go. If I go back to my page, there it is.
Still looks the same.
Looks the same, but let's see what it does in mobile here. 100.
Wow, look at that.
So that's a big difference. Let's turn on my mobile emulator and just take a look at the network tools and see what it's doing there. So I turned on the mobile emulator here, or device emulation here. I'm going to select something like the Pixel 5. And let's head over to network tools. I'll clear this out and just refresh the page. So what we should see in here is that, yeah, so it actually the browser decided that it doesn't need the biggest image. It can go and just download the smallest one. It downloaded the monkeywall-768w.webp. If we wanted to take this a step further in terms of our fallback mechanism, we could also provide fallbacks for JPEG. I'm not going to do that because I don't think it's really worth it in this case, but we could resize the JPEG to all those same sizes, and then we would just provide a second source here, tell it JPEG, and have this listed as all of those JPEG versions of the file. But I'm not going to do that. If you're on Safari on an older version, you're just going to pay the penalty and download a bigger file. Okay, now often though, with our mobile designs or responsive designs on our websites, the layout is also a little bit different between a mobile and a desktop version of the site. So I'm just going to simulate a really simple kind of mobile breakpoint here. I'm going to say that if my screen is bigger than 768 pixels, I'm only going to display that image at 50% of the width instead of 100% of the width. So just a very simple CSS change. And if we come and look at that here, I'm going to turn off my device emulator now. Right here. And if I refresh the page, so now on a bigger screen, I'm just displaying it at half width. But if I start to resize it, if I get below a certain size, you'll notice that it jumps up and uses the full width again. Mm-hmm. Okay. So in that case, we need to also specify that hint to the browser over in the images here. So, or in the sizes here. So the way we do that is we would give it a kind of a list of sizes, again, comma separated list of sizes, and we would just say min width 768 pixels. So that's same breakpoint. In that case, this is going to be view width of 50 or 50% of the view width. Otherwise, it's 100%. So now the browser has that hint again, and it knows that on the bigger pages, we can download potentially a smaller image just because we're only displaying it at half width. So a little bit of repetition there in terms of having to kind of specify that information twice, but big payoff in terms of performance benefits. So that's basically it. I'm just going to go and rerun Lighthouse in desktop. It's really nice to see the 100% in mobile. I'm hoping we also get 100% on desktop. It should be at least pretty close. We were at 97 before, so.
Ooh, suspense is crazy.
It's taking a little while this time. It's
I
odd.
wonder if it might be like rendering at different sizes because it's noticed.
Nope, something errored out there. That would explain why it didn't work. That might just be a glitch in the tooling. That was quite strange. Let's try it again. There we go, 100%.
Perfect.
Fantastic. So I'm going to include some resources in the show notes. One that is absolutely fantastic read that really kind of set me straight here on how the image and picture elements work and a whole bunch of different interesting things that I didn't know about image is this fantastic article by Stephanie Eccles on the image display element. Even if you think you know everything about images, I suggest you give this a read because you're probably going to learn something that you didn't know.
I imagine I will. All right. Well, thanks everybody for joining us on today's episode. Remember to like, comment, and share, and we will see everybody next week.
Bye.
Bye.